So in this video, we will discuss about logarithms. So Unit 4, Lesson 1. So these are the things to understand. First, determine the properties and laws of logarithms. Second, solve logarithmic equations, same base and change of base. Okay, so first concept under logarithms is logarithms itself. So let a and b positive real numbers such that b is not equal to 1. The logarithm of a with the base of b is denoted by logarithms of a to the base b is defined as the number such as that b raised to logarithms of a to the base b is equal to a. Okay? And logarithmic function, so exponential function is a one-to-one function and thus it must have an inverse which is also a function. So therefore, the inverse function is called the logarithmic function with the base b. So basically, we can interchange a logarithmic function into an exponential one and vice versa. Okay? So this is the exponential function y equals b raised to x. So interchange x and y. So we have x equals b raised to y. Then solve for y. So we have y equals logarithms of x to the base b. Okay? So we can see that from exponential function form, we can transpose it into a logarithmic one. Okay, so where x is greater than 0 and b is greater than 0 and b is not equal to 1. So we avoid b, negative values of b to avoid complex numbers, and we also avoid 1 as the value of the base to avoid the constant function. So logarithmic function, so this is the general form, y equals logarithm of x to the base b. So again, the restrictions, x greater than 0, b greater than 0, and lastly, b equals to 1. Okay, so y is what we call the exponent, exponential form, b is the base, and x is the argument. Okay, so let's change this one into an exponential one. Okay, so for example, we have 2 raised to 4 equals 16. So we need to change it into a logarithmic form. So in the logarithmic form, again, we have 3 basic variables to remember. So first, y is the exponent. So in this one, we have 4 as the exponent. Next, b base is 2 and argument x is 16. So we have logarithms of 16 to the base 2 is equal to 4. So next, 9 raised to 3 equals 129. So we have logarithms of 129 to the base 9 is equal to 3. Third, we have 5 raised to negative 2 equals 0.04. So we have logarithms of 0.04 to the base 5 equals negative 2. So next one, the fourth one, so we have 4 raised to 0 equals to 1. So transform it into a logarithmic form. So we have logarithms of 1 to the base 4 is equal to 0. And lastly, we have 25 raised to 1 half is equal to 5. So transpose it into a logarithmic form. So we have logarithms of 5 to the base 25 is equal to 1 half. Okay, and that's how we change exponential form into a logarithmic form. So next one is the basic properties of logarithms. So these properties are used to solve logarithms. Okay, so again, the restrictions. So next, so the first property is logarithms of 1 to the base b is equal to 0. So if the argument is 1, any base we have, the answer is 0. Okay? So next one, we have logarithms of b to the base b is equal to 1. So if the argument and the base is equal, so the value is 1. Okay? So next one, logarithms of b raised to x to the base b. So if the base is b and the base of the argument is equal, the result is the exponent of the argument. Okay? So next, if x is greater than 0, so we have b raised to logarithms of x to the base b is equals to x. Okay, so if the base is raised to logarithms of x to the base b, so we have the value of x. And lastly, logarithms of x to the base b equals logarithms of y to the base b if and only if x equals y. So if the bases are equal, then the argument is also equal. So next part is the natural logarithms. So ln x is equal to logarithms of x to the base e. Okay, so we must remember this. So first we have e raised to ln x is equal to x. Okay. So next, ln e raised to x equals x. So it is equal to logarithms of e raised to x to the base e is equal to x. And next, common logarithms. So logarithms of x equal to logarithms of x to the base 10. So if we have no base given, it is automatically base 10. So logarithms of 10 is equal to logarithms of 10 to the base 10. Okay, so again, remember that if there is no base in the logarithms, therefore the logarithms is always equal to 10. Okay, so now let's use these basic properties in order to solve problems involving logarithms. So first, we have logarithms of 64 to the base 4. So first, we must express 64 or change 64 into exponential 1. So we have logarithms of 4 raised to 3 to the base 4. Then we can recall the property a while ago. So we have logarithms of b raised to x to the base b is equal to x. Okay, so the bases in the logarithm and the base of the argument is equal. So therefore, the value is equal to the exponent, which is 3. Okay, number 2. So we have logarithms of 81 to the base 3. So again, the same property. So we have logarithms of 3 raised to 4 to the base 3. So the base of the logarithms is 3 is equal to the base of the argument. So therefore, the answer is the exponent. So 4. So next one, 5 raised to logarithms of 7 to the base 5. So the base is equal and the base of the logarithms is also 5. So therefore, we have 7. Okay, so in this property, just remember that the base itself and the base of the logarithms is equal, then the argument is the answer, which is 7. So next, natural logarithms of e raised to 2. So we have this property, logarithms of e raised to x to the base e is equal to x. Okay, so we will change ln to logarithms base t. So we have logarithms of e raised to 2 to the base e. So the base is, and the base of the argument is also e. So therefore, the answer is the exponent, which is 2. So next one, we have logarithms of 1 to the base 2. So recall the property. If the argument is 1, any base is given, the answer is 0. So we have 0. So next, logarithms of 1 over 256 to the base 2. So we will express 1 over 256 to a exponential form, which have the base of 2. So we have logarithms of 2 raised to negative 8 to the base 2. And we can see in the logarithms, the base is 2. And the base in the argument is also 2. Therefore, the exponent is the answer, which is negative 8. So next one, we have 4 times logarithms of 3 to the base 3. So we can recall that if the argument and the base is equal, therefore the answer is 1. So we have 4 times 1, which leads us to the answer of 4. So next we have 4 raised to the logarithms of 4 to the base 4 plus 4 raised to the logarithms of 1 to the base 4. So we have this property. So therefore, we have 4 plus 1, which is equal to 5. So next one is the laws of logarithms. Okay, so again, the restriction, let b is greater than 0, b is not equal to 1, and n is an element of real number. So for u is greater than 0 and b is greater than 0, then, so first property is, if we will adding two logarithms with the same bases, what we will do is we will just multiply the arguments. Okay, so logarithms of uv to the base b is equal to logarithms of u to the base b plus logarithms of v to the base b. Okay, so next one, if the two logarithms with the same bases is subtracted, we will divide the arguments. Okay, so logarithms of u over v to the base b is equal to logarithms of u to the base b subtracted by logarithms of v to the base b. And lastly, we have logarithms of u to base n to the base b is equal to n logarithms of u to the base b. Okay, so the exponent, we will multiply it to the logarithm itself. We will remove the exponent. So let's use this following laws of logarithms to expand each example. So first we have logarithms of 5x over 3 to the base 2. So it is divided, so therefore we will subtract. So we have logarithms of 5x over 2. Again, so logarithms of 5x to the base 2 subtracted by logarithms of 3 to the base 2. Then we can see in 5x it is multiplied, so we can also expand it. So we will add, so we have logarithms of 5 to the base 2 plus logarithms of x to the base 2 subtracted by logarithms of 3 to the base 2. Okay, so example number 2, we have logarithms of u multiplied by b squared multiplied to w cubed to the base 2. Okay, so since all variable in the argument is multiplied, so we can expect addition. Okay, so we have logarithms of u to the base 2 plus logarithms of b squared to the base 2 plus logarithms of w cubed to the base 2. Then the exponents just bring down. Okay, so 2, we have 2 logarithms of v to the base 2, and 3, we have 3 logarithms of w to the base 2. Okay, so therefore, we have this final answer. Example number 3, so we have logarithms of square root of xy cubed over c to the base 3. So first, you will change the radical into an exponential one. So we have logarithms of xy cubed over c raised to 1 half to the base 3. Okay, so we will bring down 1 half. So we have 1 half logarithms of xy cubed over c to the base 3. Okay, then we will use the subtraction since the argument is divided. So we have 1 half times logarithms of xy cubed to the base 3 subtracted by logarithms of c to the base 3. Then we will distribute 1 half to both logarithms. So we have 1 half logarithms of xy cubed to the base 3 subtracted by 1 half logarithms of c to the base 3. Then we will expand this one. So we have 1 half logarithms of x to the base 3 plus 1 half logarithms of y cubed to the base 3 subtracted by 1 half logarithms of c to the base 3. Then we will bring down 3. So the final answer is 1 half logarithms of x to the base 3 plus 3 over 2 logarithms of y to the base 3 subtracted by 1 half logarithms of c to the base 3. So next one, we have logarithms of cube root of m squared n squared over square root of p, okay, to the base x. So first, change all the radicals into an exponential. So we have m squared n squared raised to 1/3 and p raised to 1/2. Okay. So next one, so we have this property. So since it is divided, so we will subtract. So we have logarithms of m squared n squared raised to 1/3 to the base x subtracted by logarithms of p raised to 1/2 to the base x. Okay. Then use the property, so bring down the exponents. So we have 1/3 logarithms of m squared n squared to the base x subtracted by 1/2 logarithms of p to the base x. Then simplify. So we have 1/3 logarithms of m squared to the base x plus logarithms of n squared to the base x subtracted by 1/2 logarithms of p to the base x. Then distribute 1/3. So we have 1/3 times 2 logarithms of m to the base x plus 2 logarithms of n to the base x subtracted by 1/2 logarithms of p to the base x. Then simplify, so we have the final answer 2/3 logarithms of m to the base x plus 2/3 logarithms of n to the base x subtracted by 1/2 logarithms of p to the base x. So next one is we will now express the following examples into a single logarithm. So a while ago we expand, now we will combine them. So first we have 2 logarithms of x to the base 5 plus 1/2 logarithms of y to the base 5. Okay, so we have logarithms of x squared to the base 5 plus logarithms of y raised to 1/2 to the base 5. Okay, so we transform the 2 into exponent and 1/2 into an exponent. So we have now next, since it is added, we will multiply. So we have logarithms of x squared y raised to 1/2 to the base 5. And now the exponent that is fraction, we will express it into radical. So we have logarithms of x squared times square root of y to the base 5. Number 2, so we have 1/4 logarithms of a to the base 7 subtracted by 2/3 logarithms of b to the base 7. So all the multiplied constant will become the exponents. So we have logarithms of a to raise to 1/4 to the base 7 subtracted by logarithms of b raised to 2/3 to the base 7. Next, we have this subtraction. So we will divide the arguments. So we have logarithms of a raised to 1/4 over b raised to 2/3 to the base 7. Then the exponents which has a fraction will transform into radicals. So we have logarithms of 4th root of a over cube root of b squared to the base 7. Example number 3, we have 3 ln a plus 4 ln b plus 6 ln c. Okay? So the constants will become the exponents. So we have ln a cube plus ln b raised to 4 plus ln c raised to 6. Okay? So next, since it is all added, so we will multiply. We have ln a cube, b raised to 4, and c raised to 6. So number 4, we have 4 over 3 logarithms of m to the base x plus 4 over 5 logarithms of n squared to the base x subtracted by 1/4 logarithms of p cube over x. Okay, then the constants will become the exponents. So we have logarithms of m raised to 4 over 3 to the base x plus logarithms of n squared times 4 over 5 to the base x subtracted by logarithms of p cube raised to 1/4 to the base x. Then simplify. So we have this one. Then since the first two is added, so we will multiply the arguments. So we have logarithms of m raised to 4 over 3 n raised to 8 over 5 to the base x subtracted by logarithms of p raised to 3 over 4 to the base x. Since they are subtracted, divide the arguments. So we have logarithms of m raised to 4 over 3 n raised to 8 over 5 over p raised to 3 over 4 to the base x. Then change all the exponents, which is fraction, into a radical. So we have logarithms of cube root of m raised to 4 multiplied to fifth root of n raised to 8 over 4th root of p raised to 3 to the base x. So next one, solve the following logarithm equation using the properties and laws of logarithms. Okay, so first we have logarithms of square root of 27 over 9 to the base 3. So since it is divided, so we will subtract them. Logarithms of 27 to the base 3 subtracted by logarithms of 9 to the base 3. So square root of 27 is square root of 27. So we have logarithms of 27 raised to 1/2 to the base 3 subtracted by logarithms of 9 to the base 3. And we have 27 is 3 cube. So we have logarithms of 3 cube raised to 1/2 to the base 3 subtracted by logarithms of 9 to the base 3. Then multiply. So we have logarithms of 3 to the base 3 over 2. So we have logarithms of 3 raised to 3 over 2 to the base 3 subtracted by logarithms of 3 raised to 2 to the base 3. So the final answer is 3 over 2 minus 2, which leads us to negative 1/2. So example number 2, we have logarithms of 16 times square root of 32 to the base 2. So since they are multiplied, so we will add them. So we have logarithms of 16 to the base 2 plus logarithms of square root of 32 to the base 2. The square root will become an exponential 1. So we have logarithms of 16 to the base 2 plus logarithms of 32 raised to 1/2 to the base 2. Then simplify. So we have logarithms of 2 raised to 4 to the base 2 plus logarithms of 2 raised to 5 raised to 1/2 to the base 2. Then simplify this. So we have logarithms of 2 raised to 4 to the base 2 plus logarithms of 2 raised to 5 over 2 to the base 2. Then use the property. Okay, so we have 4 plus 5 over 2, which is equal to 13 over 2. So next we have change of base. So let a, b, and x be positive real numbers with a is not equal to 1 and b is not equal to 1. So we have logarithms of x to the base b is equal to logarithms of x to the base a all over logarithms of b to the base a. Okay? So first example, we have logarithms of 32 to the base 8. So using change of base, we have logarithms of 32 over logarithms of 8. So we will be using 2 as their bases. So we have logarithms of 32 to the base 2 and logarithms of 8 to the base 2. Then we will change 32 into a exponential form which has the base of 2. So we have logarithms of 2 raised to 5 to the base 2 and logarithms of 2 raised to 3 to the base 2. Then we have 5 over 3. Okay? So we have number 2, logarithms of 1 over 27 to the base 81. So we have change of base is equal to log 1 over 27 over log 81. Okay, then change them into same bases, exponential. So we have logarithms of 3 raised to negative 3 to the base 3 all over logarithms of 3 raised to 4 to the base 3. So we have negative 3 over 4. So next one, we have logarithms of 1 over square root of 5 to the base 25 plus logarithms of cube root of 9 to the base 243. So we have logarithms of 1 over square root of 5 to the base 5 all over logarithms of 25 to the base 5 and plus logarithms of 3 to the base plus logarithms of cube root of 9 to the base 3 all over logarithms of 243 to the base 3. Then simplify. So we have negative 1/2 over 2 plus 2/3 over 5. So negative 1/4 plus 2 over 15 is equal to negative 7 over 60. So next is logarithmic equation. So use the properties and laws of logarithm to evaluate the following. Okay, so we will apply all the properties and laws that we discussed a while ago. So first one, we have logarithms of x to the base 2 is equal to negative 5. Okay, so the first thing to do is we will change this one into an exponential form. So we have 2 raised to negative 5 equals x. Okay, so then solve 2 raised to negative 5 is 1 over 2 raised to 5, which is x equals 1 over 32. Next, number 2. So we have logarithms of 16 to the base x equals 2. So again, write the logarithmic form into exponential. So we have x squared equals 16. Then square root both sides. So we have x equals positive negative 4. So their equation should have not a negative base. So therefore, the base is only 4. Okay? So next example, we have logarithms of x raised to 4 equals logarithms of 6561. Okay? So again, if they have the same bases, so we will just get their arguments. Okay? Since x raised to 4 equals 6561. So we have x raised to 4 equals 6,561. Then solve for the value of x. So 4th root both sides. So we have x equals positive negative 9. So number 4, we have 2 raised to x equals 250. Okay, so in this kind of problem, we will just need to rewrite them into an logarithmic form. And that's it. So x equals logarithms of 250 to the base 2. So next example, logarithms of x plus 100 to the base 10 equals 3. So write the logarithmic equation into an exponential one. So we have 10 raised to 3 equals x plus 100. Okay, so 10 raised to 3 is 1,000. So transpose 100. So we have 1,000 minus 100 is equal to x. So 900 equals x. So number 6, we have logarithms of x minus 4 to the base 2 plus logarithms of x plus 4 to the base 2 equals 0. Okay? So we have this property. Since they are added, we will multiply the arguments. So logarithms of x minus 4 times x plus 4 to the base 2. Okay? So logarithms of x squared minus 16 to the base 2 equals 0. So 2 raised to 0 is equal to x squared minus 16. Okay? So 2 raised to 0 is 1. So we have 1 equals x squared minus 16. So transpose 16, we have x squared equals 17. Then square root both sides, x equals square root of 17.